So let's continue with our revision topic chapter 1, measurement. Today we're going to continue with another subtopic, basically the new concept for the physical quantities. But before that, let's review what we already learned before. First, we learned about physical quantities. So basically, physical quantity is a quantity that can be measured. It must have, so it can be measured objectively. Means that we can use instruments, measuring instrument to take measurements. So it must have magnitude and units. So we talked about units before. Basically, we have two types of units, metric and imperial. So metric basically the unit that we already encountered in daily life, such as cm, second, degree Celsius, volts, etc. But in this metric system, we also have SI unit, which is already defined for all the base quantities, such as meter, kilogram, second, Kelvin, mole, ampere, candela. So how many? 1, 2, 3, 4, 5, 6, 7. So we have 7 base quantities. So we have 7 base SI units. So in metric units, all of the metric unit doesn't mean that it is the SI unit. So it's look like this. If you draw a set notation, all of this is metric, but inside the metric we have SI unit. Only a small portion of the metric is chosen to be the SI unit. So imperial is very old units that used before the metric unit. So such as feet, inch, yard. What else? Acre. Let's see, acre, gallon, ounce, etc. So a lot of the imperial units, even though rarely used, but it's still used in some countries such as USA. Okay, so today we continue to extend our physical quantities. Yesterday we learned about base quantity and derived quantity. So let's list down some of the examples. So base quantity, length, mass, temperature, time, current, amount of substance, and luminous intensity. So we have 7. Derived quantity contains various that come from base quantities, usually through multiplication or division. So for example, velocity, acceleration, force, momentum, what else? Work done, power, voltage, charge, kinetic energy, potential energy, gravitational potential energy, what else? Weight, pressure, density, volume, area, what else that we can think of? Resistance of a conductor, resistance for a conductor. Let's think about something else. Concentration, or molarity, and some many more that we then didn't specify here. Okay, so today we continue with our new category, basically scalar quantity and vector quantity. So what is scalar quantity? So scalar quantity is quantity that has magnitude only. Only means that magnitude and unit. The magnitude and unit must be not separate. So basically, it's only have magnitude, doesn't have direction. So it is still a physical quantity. So let's list some example. All the base quantity are scalar quantity. So we know about that. But not all the derived quantity are scalar quantity. So let's mark which one is the scalar quantity. So we have power, voltage, charge, pressure, density, volume, area, resistance, and molarity, concentration. So all of these marked over here are scalar quantity because they don't have direction. So we can add one more, energy as well. It's also a scalar quantity. Okay, so basically all the 7 base units is automatically become scalar quantity, but only certain of the derived quantity are scalar quantity. So number 4, we introduce vector quantity. So it has magnitude and direction. So basically we define direction by positive or negative. Okay. Means that positive is in the positive direction, right or above or top. Minus is in the negative direction, which is below or left. But how about negative temperature? So negative temperature is not a vector quantity because the negative defines the temperature below the ice point. So it's not any sense of direction. So temperature is just a relative scale. So basically we just compare everything with the zero. So it looks like it has a positive direction or negative direction, but actually it's not. It's just above zero or below zero. That's why in terms of SI unit, we choose the scale Kelvin because Kelvin doesn't have negative sign. So it makes the quantity, the physical quantity, a scalar quantity. So basically the one that we don't mark actually a vector quantity. So we have velocity, acceleration, force, momentum. This is scalar quantity. Sorry, this is work done. So work done is a scalar quantity, but weight is not a scalar quantity. It's a vector quantity because weight and force are the same. They are the same thing. And also G, gravitational acceleration is the same as acceleration, ordinary acceleration. We can add one more, displacement. S is also a vector quantity, but basically S is come from the base quantity, but since it has direction, we don't include that in the base quantity. So it's just a solely vector quantity. It doesn't have any pairs with the base or derived quantity, but the unit is the same as the length, which is meter, SI unit. Okay, so I think that's all for today. It's very short video. We just want you to introduce 2 new types of quantities, scalar quantity and vector quantity. So this quantity over here is heavily on chapter 2 and 3. Basically, Everything that has a direction, such as force, such as push or pull, we can make it push positive or pull negative, or force to the right is positive, force to the left is negative, force to the top or above, upwards is positive, force downwards negative. We can do that. So basically this chapter, and motion as well, motion to the right, left, upwards, downwards, vector quantity, we can describe it in terms of vector quantities. Yeah, it has a specific direction. So what else that we can add here that is not a vector quantity that is paired with the vector is their own respective vector quantity. Speed. Also letter V, I guess, V. But this V over here, usually we have a bar, the arrow on above to represent it as a vector quantity. F arrow, momentum arrow, and weight arrow, G arrow on the top. So everything that has arrow on the top is basically a vector quantity. But you can also neglect the arrow and just write down the symbol to represent vector quantity. It's also okay. But in case we want to differentiate between speed and velocity, because both have the same letter, it can make the velocity has an arrow shape on top, whereas the speed doesn't have the arrow shape. So distance, speed and distance are scalar quantity. Okay. So I think that's all for today. Hopefully that you remember all types of category for physical quantity, base quantity. You must memorize all with their symbols, with their SI units and SI symbols. Derive quantity, how to derive quantity using formulas in terms of base SI units or their own units such as Newton, Joule, Watt, so whatever. Scalar quantity, what are the examples? Vector quantity, what are the examples? Okay, so that's all for today. Hopefully to see you soon. Thank you.